Alright, I'll try and explain this one in a different way. So here we've got 5 diners and 5 meals, or 5 different main courses. It does say the probability that exactly one of the main courses is not chosen. So exactly one, so all the other ones have to be chosen. So the other 4 have to have at least one person choosing them. Alright, so what you could think of if there wasn't that condition, we would have each diner would have 5 choices. So 5, so first person would have 5 choices, the next person would have 5 choices, 1, 2, 3, 4, 5. They would all have 5 choices. So you can see that the denominator is going to be 5 to the power of 5. Okay, so if I look at the numerator, I can think about, first of all, that there's how many different ways to skip out one of the meals. Well, I could skip the broccoli meal or the cauliflower meal or the chocolate main course, whatever it is. So there's 5 different ones. So there's 5 ones I could that could be missed. There's 5 meals that we could leave out. So now we'll just pretend to leave one out. Okay, so now we've decided, not us deciding, but one of them has been left out. So there's only 4 choices. So if you think about it, we've got 5 people choosing 4. So one of those 4, you could think of them as groups. One of those 4 groups or meals has to have 2 people eating them. So why don't I take those 5 people and choose those 2 people first? All right, I'll choose those 2 people. They can have meal, let's say now, we started off with meal A, B, C, D and E, and we said there are 5 different ways. We could leave out A or B or C or D or E. 5 different ways. Now I'll just take one of those ways, so I'll leave out E, and I'm going to make 2 people choose A, and then there'll be 3 people left. So 3 people can go in group B, 3 people choose 1, so 1 person out of those 3 left can choose. We're going to kind of make them go into group B or eat meal B. 2 people left can eat meal C, and then of course 1 person will have to go for D, and I hope they enjoy it. Now at the moment I've got 2 people having A, so if you think about it, those 2 people could be in group A or eating A, or they could be eating B or C or D. So there's 4 choices for the 2 people. All right, so I've got to kind of add that in as well. So I think I've taken care of everything now. So we can just pop that in the calculator. Now when you do pop that in the calculator, I'll have to do it on this side. 5 to the power of 5 is 3125. And 5 times 5 choose 2 times, which is 10, so 5 times 10 times 3 choose 1 would be 3, times 2 choose 1 would be 2, times 1 times 4 should be 1200. Yep, should be 1200. All right, and yep, I agree with that. So if we simplify it, we get that. Sorry, I just went backwards there. Hope that's okay. So when it says repeat it for n diners and n main choices, I can kind of be a little bit rough with it and just go exactly off this. So n, we originally had 5 and 5, and now we've got n and n. So I'm going to go n times, because that's for that 5. And then I'm going to do n choose 2, 5 choose 2, so that's n choose 2. And then you can see I'm going to take away those 2 diners and choose 1 each time now, but there's lots, right? So then I'm going to go 1 less than that, so that'll be n minus 3, choose 1. And I'm going to keep doing that until I get to 1 choose 1, right? That's going to be the lowest. And then I times by 4, which is 1 less than 5, right? Because I kind of looked at if I took 1 out. So take 1 out of n, and you've got n minus 1. And then don't forget your denominator. All right, so on our denominator, of course, we've got, this was 5 to the power of 5, so we've got n to the power of n. Now, we definitely want to simplify that a little bit. So if I just look at the top there, I'll just do it along here. It's going to be hard because you won't be able to see. I'll make it a little bit smaller. Here we go. So I've got n, that's fine. Now n choose 2 is the same as, if you think about it, as n factorial on n minus 2 factorial, and then 2 factorial. Then I'll have the n minus 2 choose 1, so that's n minus 2 factorial on n minus 2 minus 1, so that's n minus 3 factorial, and then 1 factorial, which is just 1, so I won't write it down. And the next one would be n minus 3 factorial, and then n minus 3 minus 1, so n minus 4 factorial or 1 factorial. And we will keep going like that until we get to this one will be 1, and then we'll have n minus 1. So I can't fit it in. I'll just put the n minus 1 there. So you can see what's going to happen, and it's all on n to the n, is that each of the, as you keep going, the denominator is going to cancel with the numerator of the next one. So it's n minus 2 factorial, n minus 2 factorial. There's just a little bit of difference with the 2 at the front. So if I look at what we've got left, we've got this n. We're going to have n factorial on 2 factorial. So I'll put the 2, which is just 2. So I'll put the 2 at the bottom with the n to the n. And don't forget this last term here, which is n minus 1. So that's your answer. You can play around with it and make it look differently if you want. I know the answer is equivalent in the textbook but looks different. That's fine. Alright, so you could play with that n factorial. You could make it instead n minus 1 factorial, and then you're going to have an n squared, or you can have an n minus 2 factorial. You can keep changing it around as much as you like, but that is fine. That is also a very valid answer. Alright, hope that helps.